Good afternoon everyone. So today I am going to start the reflection of light. So first of all I would like to say that what is light? So light, it is a source of energy and also it is an electromagnetic wave. Light, that is the source of energy and it is an electromagnetic wave. So what do you mean by the electromagnetic wave? Electromagnetic wave means it is the combination of the electric field and the magnetic field. Electric field and the magnetic field both will be perpendicular to each other. Suppose this is your direction of the electric field and this is the direction of the magnetic field. So the direction of the propagation of the light, that will be perpendicular to the both E and B. Suppose we represent perpendicular to the E and B by the cross. So this will be the direction of propagation of light. So in the case of the electromagnetic wave, this electric field is converted into the magnetic field and the magnetic field is converted into the electric field. In this way, the electromagnetic wave propagate, and the direction of the propagation of the electromagnetic wave, it is perpendicular to the both electric field and the magnetic field. Second thing, that the range of the electromagnetic the range of electromagnetic wave is very large. So light is that part of the electromagnetic wave spectrum which lie in the visible range. So light is that part of electromagnetic wave spectrum. A spectrum represents the range of the electromagnetic wave. So light is that part of the electromagnetic wave which lies in the visible range. Visible range means visible, it is about the wavelength, and that lies between 4 into 10 to the power minus 7 meter to 8 into 10 to the power minus 7 meter. So this is the range of wavelength. This is your range of wavelength. This range of wavelength that lies in the visible range of the electromagnetic wave spectrum, and that is your light. So this is about the brief idea about what is the light. Now we are coming the reflection of the light. So if anybody asks, what is the reflection? So reflection means, suppose this is an object. So just we have taken, this is an object, and the front portion, that is the reflecting surface. Suppose any incident ray that incident on this object. So after falling, this light, and this light is coming from the source. The source can be anything, it can be sun or it can be any light also. So this light is coming from the any source, and when this light incident on the object, this light will come back. This light will come back to the opposite direction. So we can say, what is the reflection? The sending back of the light after the light incident on the object, that is called the reflection of the light. Reflection of the light means sending back light after incident on it. That is called the reflection of light. So this reflection of light, this property of the reflection of light, it depends on the type of the surface on which light incident and the type of the mirror on the light incident. This type of the mirror, that will be plane or that will be curved. So first we are coming, if the light incident on the plane mirror. So first we are coming the plane mirror. So what is the plane mirror? Suppose this is your plane mirror. This plane mirror has the two surfaces. This surface is called the reflecting surface. And this back surface is the silvered surface. This back surface is the silvered. Because on the back surface, a very thin layer of the metallic silver layer is deposited on the back surface. And the front surface, that is called the reflecting surface. So this is your plane mirror, and we can say that in the case of the plane mirror, the radius of curvature, that will be infinity. Of plane mirror will be infinity. Now we are coming the image formation in the plane mirror. Image formation in plane mirror. So before coming to the image formation, I would like to take two things, that there are two types of the image formation takes place. There are two types of the image formation takes place, and the first one is that is called the virtual image, and another one is called the real image. So virtual image, that is formed by the intersection of the virtual ray. This is formed by the intersection of virtual ray. Also, second important point, that always image formation takes place when the two rays intersect at one point. Minimum two rays that intersect at a point, then only image formation takes place. Virtual image is formed by the intersection of the virtual ray, and the real image is formed by the intersection of the real ray. Real image is formed by the intersection of real ray. Real ray means original ray. Now we are coming the image formation in the plane mirror. Suppose this is your plane mirror. Suppose a object is placed at this point. Suppose this is your object O. So the image formation that takes place at the same distance, image formation that takes place at the same distance in the case of the plane mirror. Suppose this distance is your L from the mirror. We have to measure the distance of the object or the image from the mirror. So the distance of image, that will be also L. Distance of the object, that will be equal to distance of the image. So property first, property object distance from equal to image distance from mirror. Second property of the plane mirror, that the size of object will be always equal to the size of image. Size of object that will be equal to size of image. So this is second property. Third property, in the case of the plane mirror, the image will be always virtual image. The image will be always virtual image. So property number 4, if I say that object is moving with a velocity of v towards or away from the mirror, so image will also move with the same velocity. Means we can say that the velocity of object, that will be equal to velocity of image. So this is the fourth property. Velocity of object equal to velocity of image. So these are the properties in the case of the plane mirror. Now we are coming the law of reflection. So what are the law of reflection? So there are two laws of reflection. There are two laws of reflection. So just I am plotting one diagram. Suppose this is your plane mirror. This is your plane mirror. Suppose this ray A, this is called the incident ray. The ray which are coming from the source and incident on the mirror, that is called the incident ray. Incident ray, that is the ray which are coming from the source, that is called the incident ray. So this is your, we can say this is the incident ray. So after reflection from the mirror, so this is your reflected ray. This is your reflected ray. I draw one line which is perpendicular to the mirror and passing through at the point of incidence. Suppose this point is O, point of incidence that lies on the mirror, and that point is O. So I plot one line which is perpendicular to the plane of the mirror and it passing from the point of incidence. So just name as this is your N. NO is the normal at the point of incidence. Suppose this I name as this is your A and this is your B. So our AO is the incident ray, OB is the reflected ray, and NO is the normal at the point of incidence. Okay. So here NO, that is normal, at the point of incidence. One more thing, that the angle between the incidence ray and the normal, that is called the angle of incidence. This is called angle of incidence and it is represented by I. And the angle between the normal and the reflected ray, that is called the angle of reflection, and that is represented by R. So here I, that is your, it is the angle of reflection. And R, that is your angle of, so this is your angle of incidence. And this is your angle of reflection. Now come to the first law. What is the first law? First law of reflection. The first law of reflection says that incident ray, reflected ray, and a normal at the point of incidence all lie in the same plane. Incident ray, reflected ray, and normal at the point of incidence all lie the same plane. So this is our first law of the reflection. What is the second law of reflection? Second law of reflection says that the angle of incidence that will be equal to angle of reflection. Means we can simply write I is equal to R. This is the second law of the reflection. Now based upon this two law, we can prove that in the case of the plane mirror, the size of image that will be equal to the size of object. Suppose this is a plane mirror. And just we consider this is the object. This is placed in the front of the reflecting surface of the plane mirror. Suppose one ray that passes from this point. And from the law of reflection, we know that the angle of reflection will be as this will be the reflected in this direction with the same angle. It means this ray will appear to come from some point somewhere, this point. So this dotted line represents that it is a ray, but actually this is not ray. This is called the virtual ray. This is the dotted line represent that this ray is the virtual ray, and the bold line this represent that the ray is the real ray. Dotted line this represent the virtual ray, and this bold line represent that is the real ray. Again, just change the color of the object. Again, suppose second ray that moves from this point, and from the law of reflection we know that it moves in this direction. Again, so again this line is this dotted line represent this is your virtual ray. So we plot one more ray. Suppose this is your one more ray, and after reflection again it will passes from this point and it appear to come from this point. So for this position also we will take one more ray, and we observe that it appears to come from this point. So we get the final image as this one. Suppose the object is AB and the image is A dash B dash. Here the size of AB is equal to A dash B dash. AB is equal to, it is A dash B dash. So we can say that in the case of the plane mirror, the size of the object that will be equal to the size of the image, and that has been proved, by the law of the reflection. Second thing, I say that this dotted line represents the virtual ray and this bold line represents the real ray. So I write here this dotted line, this is your virtual ray, and the ray represented by the bold line, that is your real ray. as this image is formed by the intersection of the virtual ray. So we can say that here image will be virtual image. This image will be your virtual image. Because it is formed by the intersection of virtual ray. So this is about the plane mirror. Now we are coming the curve mirror. So in curve mirror there are two types of the mirror. So first is called the concave mirror. And the second one is called the convex mirror. So in the case of the concave mirror, the polished surface is, that is your convex surface. The polished surface is the convex surface and the reflecting surface is the concave surface. So their name is the concave mirror. But in the case of the second mirror, the convex surface is the reflecting surface. So their name is the convex mirror. In another word, we can also define that what is the concave mirror. Concave mirror, it is the part of the spherical mirror. Suppose I just draw a spherical mirror. And this is your polished surface. The outer surface is the polished surface. And suppose I cut the mirror from there. I cut here. If I cut mirror from here, and suppose this is the center of this is the center of curvature of this spherical mirror. So we can also define that what is the concave mirror. So concave mirror, it is the part of the spherical mirror. It is the part of the spherical mirror because we cut from this sphere. It is the part of the spherical mirror whose reflecting surface, this is the reflecting surface, whose reflecting surface is near the center of curvature. Okay. In the same way, we can define that what is the convex mirror. So convex mirror, it is also the part of the spherical mirror whose reflecting surface is beyond the center of curvature. So in this way, we can define the both type of the concave mirror and the convex mirror. Now we are coming the nomenclature of the concave mirror. So come to the concave mirror. So this is your concave mirror. So first, the center part of this mirror, that is called the pole of the mirror. Suppose this is the center of the mirror, that is called the pole of the mirror. Suppose there center of curvature, Suppose this is the center of curvature of the concave mirror C. C is the center of curvature of the concave mirror. So the line joining the center of curvature and the pole, that is called the principal axis. So line joining from the center of curvature to the pole, that is called the principal axis. And this distance is called, from the center of curvature to the pole, this is called the radius of curvature. So this is about the nomenclature of the concave mirror. Now, how the image formation takes place? How the image formation takes place? So we are coming the image formation in concave mirror. So for the image formation in the case of the curved mirror or in the case of the concave mirror, first we know what is the rules for drawing the image, rules for the image formation. So first we will come the rules for formation of image. So what are the rules? So come to the first rules. A. Oh, this is your concave mirror. And this is your principal axis. This center curvature suppose these are parallel beam of light. These are the parallel beam of light. So all the parallel beam of light, parallel means it is parallel to the principal axis and very close to the principal axis. Means these rays are parallel to principal axis and also very close to principal axis. So these rays which are parallel to the principal axis and very close to the principal axis. So after reflection from the mirror, it is passing from a common point on the principal axis and that is called the focus. So after reflection from the mirror, it is passing from a common point. All the parallel ray and this is called the focus. All the parallel ray which is parallel to the principal axis and very close to the principal axis, after reflection from the mirror, it is passing from the common point on the principal axis, that is called the focus. Okay, so we can write here all the parallel ray parallel to the which is parallel to principal axis and also very close to principal axis. So after reflection from mirror, it passes through a common point. On principal axis, which is called focus. So this is the first rule for the image formation. So this is your first rule. Now come to the second rule. Come to the second rule for the image formation. So suppose this is your concave mirror. This is your principal axis. This is your center of curvature and this is the pole. If any ray which passes from the center of curvature, which passes from the center of curvature, it retraces their path. It retraces their path after the reflection from the mirror. If ray is passing from C, then after reflection from mirror, it retraces their path. So this is our second law for the image formation. So come to the third law. Third law for image formation. Suppose this is your concave mirror. This is a center of curvature and this is your pole. If any ray which are coming from the infinity, suppose these rays are coming from the infinity. So the after reflection from the mirror, it forms a very small image on the focus. It forms a very small image on the focus. Means if the ray are coming from the infinity, the final image is formed on the focus, and the size of image that will be very, very small. In the same way, we can determine that if any ray which is passing from the focus, so after reflection from the mirror, it will be parallel to the principal axis. Suppose this is your mirror, this is your pole, this center of curvature, this is your focus. Suppose any ray which is passing from the focus, so after reflection from the mirror, it will be parallel to the principal axis. So these are the complete rule for the formation of the image in the case of the concave mirror.